This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Roshan Senanayake.
What's up, listeners? Welcome to Season 4 of Inspiring Design with Roshan Senanayake. This is where the best of the best brands, experts, change makers, and thought leaders come together to share their valuable insights, experience, and knowledge, all centered around the growth sector in advanced manufacturing within Industry 4.0, encompassing various industries, technologies, skills, knowledge, trends, as well as stakeholders, all the while linking it back into education within schools and universities. Today's episode is an international recording, and this time we connect with a very special guest and entrepreneur, Rory Aronson, all the way from California, USA. Rory is a mechanical engineer and social entrepreneur focused on large-scale social and environmental challenges. He aims to benefit humankind and the environment by taking his ideas into action via engineering, design, entrepreneurship, and personal lifestyle choices. Not only that, Rory is the founder of FarmBot Incorporated. FarmBot designs and manufactured 100% open source farming robots for home, educational, and research purposes. These machines, available in a variety of sizes, can plant, seed, water, measure soil moisture, and take photos to identify weeds and then abate them. Users control their own system from a web-based application right from the comfort of their own home devices, such as phones, tablets, or even your laptop. So without further ado, let's get straight into it. Rory, welcome to Inspiring Design. Rory, welcome to Inspiring Design, mate. Can we start off with a little bit of background? What's your story?
Yeah, sure. Well, thank you for having me. So I studied mechanical engineering at Cal Poly in San Luis Obispo in California. I graduated in 2013, and right after school, I wanted to start my own business. So I had several different ideas, but the one I decided to go running with is FarmBot. I actually came up with the idea while I was in school. I was taking, the usual engineering classes, but I also took an organic agriculture class, and I was also working at my local makerspace and playing around with 3D printers and laser cutters and CNC routers. And also at home, I was gardening, by hand with a hose and a shovel, and people usually garden in the backyard. And, between work and school and life, I'd go out of town for the weekend and the garden would suffer. When I would start off the season, there was a lot of energy, momentum behind it, excitement, put the seeds in the ground, really take care of everything really nicely. And then as time went on, week 3, week 4, week 5 into the growing season, get lazy, go out of town, forget to water, the weeds start taking over everything. And so I thought to myself, man, there's got to be some kind of 3D printer or, CNC router for the garden. And so I looked up on Google and tried to find something of that nature, and was kind of surprised that nothing really existed like that. And so that's where FarmBot came from, and started running with that idea and graduated from school and have been working on it ever since.
Awesome. So how long has FarmBot been around?
So we became a company in early 2016, and we started selling product to customers in July of 2016.
Awesome. And are there any aspirations towards coming to Australia?
Absolutely. Yeah. Right now we do sell globally. So we ship to customers all over the world. Our team is mostly based in the US, but we do have a team member in Belgium and another one up in Canada. And we work with people all over the world. And our customers are everywhere. So hotspots definitely in the United States and Europe, but also in Australia, New Zealand, Japan, China, India. It's kind of all over the place.
Love that. Love that. And I think one of the biggest things, this kind of thing, it would be perfect for a school environment for students to know about a whole array of different technologies and the agricultural component. So before we get on to those exciting things, I actually wanted to ask you from your expert opinion, this particular industry you're in currently, you know, it's a combination of tech and engineering and agriculture kind of amalgamated into one. But what did this industry look like from your point of view, let's say 50 years ago?
Oh, 50 years ago, yeah, very different. 50 years ago was around the time of the Green Revolution. So what was happening in agriculture was the simplification of the farm. So, really long ago, the farm used to have a big diversity of plants, of crops, of animals. It was an ecosystem. And with the Green Revolution and with the advent of these very capable, large mechanized tractors, people started simplifying the farm. So historically, or typically, machines are very good at doing one task very, repetitively. And so if you're trying to design a tractor to take care of a plot of land, and are you going to design a tractor that can pull weeds and plant corn seeds and harvest zucchini squash and prune pepper plants and do 500 other things? No, that's going to be very difficult to do. You're probably going to come up with a implement that can be towed behind the tractor that does one task, and it does it really well, and it can do it at scale. So that's basically what happened is the farm got turned into basically a monocrop, right? Vast swath of land where there's a single crop type on the land, and then you have these machines that can do single operations at scale. And there's a trade-off there, right? With a ecosystem type farm where you have a bunch of different crops, farm animals, etc. The animals are going to be fertilizing the land. The crops can be chosen to help each other out with beneficial insects, or one provides shade for the other, or one pulls a certain nutrient, for example, nitrogen from the land. And then the next season, you use a legume to put nitrogen back into the soil. And it's, you can manage it in this sustainable way. But with the simplification of the farm down to a single crop, a lot of those sort of natural biological benefits went away. And that's where the Green Revolution came in with, okay, we need to supplement with synthesized fertilizers and, pesticides and all sorts of things to basically stabilize the system. Because it's, you never go out in nature and find just a single crop or, a single bug somewhere. It's always an ecosystem of various, of diversity. So 50 years ago, it was kind of this transition from farms that were taken care of very intensively by people. Lots of people used to work in agriculture. Thousands of years ago, it was almost everyone was a farmer. Today, it's about 2% of people, at least in the United States, are working in agriculture. And that's good in a lot of ways. It allows people to branch out and pursue engineering and the arts and all of the other things that people do. But it has come at the cost of sustainability for the environment, the health of the produce that we are making, and all sorts of other ramifications. So fast forward to today. technology is very different, right? We have the internet, we have these very low cost small computers that we can put, the Raspberry Pi, it can fit in your back pocket, and it has plenty of computing power to connect to the internet and hold a bunch of information about how to grow plants. You can have a neural network running on a small device like an iPhone that can, process images very quickly and make smart decisions. So the ability for technology today to manage a polycrop is a lot greater. So, I talked about you would never make a machine that can do X, Y, Z, A, B, C tasks because it's infeasible. Well, that was the case 50 years ago, but today it's very different, and we actually can do stuff more like that. So that's kind of where FarmBot fits back in.
Can you detail the technologies that are part of what the industry looks like now? So you obviously mentioned things like the specific devices, the internet obviously coming into things. What are the actual technologies that play a role in this industry now?
Right. There's a lot of different things going on in the agriculture ag tech space.
Mm-hmm.
Obviously, we have FarmBot, but on more of an industrial scale, there are drones.
Mm-hmm.
So people will fly drones over a field, and the drones are equipped with cameras and hyperspectral imaging equipment. So they can take photos and videos of the crops and the land and identify pests, or where there's a problem, where something needs more fertilizer, or the fruits are ripe. They can identify what's going on in the field and then essentially create a prescription.
Mm-hmm.
And then other equipment, for example, irrigators, or another drone that flies over with some type of pesticide, or a tractor that's going to drive over and do planting at various intervals.
Mm-hmm.
All this information will be combined into a prescription that gets then utilized by other equipment to take care of the farm and plant the crops accordingly in a way that's going to be optimized.
Yeah.
Pursuing the biggest yield, or a certain cost efficiency with the output.
Yeah.
So drones is a big new technology that's powered by very precise GPS systems.
Mm-hmm.
GPS RTK is the technical term, which allows you to get sort of like accuracy within plus or minus 10 centimeters,
Wow.
which is better than the GPS in your phone. There's also satellite imagery that does some of the same. So of course, tracking the weather and zooming in even more now to the crop level and the field level. There's all sorts of smart connected sensors. So farmers can have these little boxes and these sensor modules that get stuck in the ground at various points in the field, and they're all internet connected. So they'll report back, the soil moisture content, the temperature, the ambient light. And with all that information, you can figure out, okay, when is, you can figure out with more precision, when is a good time to replant? How is the soil health doing? How are the crops doing? Do we need to water more or less? The weather report said it was going to rain, but did it actually rain? How much?
Mm-hmm.
All of these different technologies create a lot of data, and then you can act on that data. Probably the last piece of the puzzle there would be AI and machine learning and big data type analytics.
Yeah.
So with all of this data, all these sensor readings, information about crops, genetics as well, you plug all that stuff into an AI model, and if it's been sufficiently trained, it can help make decisions about how to manage the farm, manage the crops better than an individual can do. And it can do it at scale. It can do it instantly. It can do it several times a day. So the job of the farmer is becoming more and more technical. It's about managing economics of the farm. It's about managing supply chain, about selecting the best technology and equipment, and sort of setting up all of these pieces of technology that talk to each other. The sensors talk to, the data analytics platform, which talks to the tractor equipment, and the tractors, basically drive themselves these days. So
Yeah.
yeah, it's become a lot more of a, like an IT job than it
Mm.
is what you might think of as a farmer, out there with in the dirt necessarily.
Yeah, and I think that's the scary part for a lot of people because of this huge transition on what this industry used to look like. And it was very analog and a lot of blood, sweat, and tears. And so now it's become a whole different beast. So, diving into what's actually required for being successful in that industry, in your opinion, what are the key skills and attributes? I know you've kind of already touched based on it briefly just there, but especially if someone's, let's say, in high school now, or even primary school, or studying in university, given what the industry is going to look like in the next 5, 10, 20 years, what are the key skills that they're going to need to focus on?
I think it's going to be very technology focused.
Mm-hmm.
There will be aspects of biology and soil science and plant science, but all centered around how do we use these sciences and plug them into a technology platform
Mm-hmm.
that can automate a lot of these decisions. Because at the end of the day, most people don't want to do manual, tedious, repetitive labor of any kind, right? Whether that's working on the computer and doing something tedious, or it's working in the field, doing some type of manual physical process. Most people don't want to do that. That's why definitely here in California, there's a shortage of farm labor, or that's one contributing factor. It's why most young people don't think of themselves as going into the ag sector
Mm-hmm.
as a career path, because they think of and farming in the future as still this manual process
Yeah.
that's backbreaking and difficult and not mentally engaging.
Mm-hmm.
But I think the way the industry is going is that it's a lot of what farming will be managing um, software products. It will be managing technology, robots,
Yeah.
fleets of sensors and drones. And so I think any kind of technology, experience with technology and sort of the cutting edge of computing power and AI and sensors and data analytics, those are all the skills that are going to be needed for producing food efficiently at scale, in these automated ways that use technology to do the actual physical labor, parts.
Yeah. And I think this is one of those industries that, due to the involvement of technology, all the repetitive tasks, like you said, they've become, instead of manual labor that we as humans had to do, they've now become replaced by automation and some sort of technology that can look after it, like you said, multiple times a day without a worry, just keeps doing it over and over again. But at the same time, even though that in itself has become a job loss, I think it's created another 3, 4 different types of jobs just to be able to manage that and successfully make sure they're integrated, implemented, built. The technologies keeps evolving. So I'm loving what you're putting down. So if
Absolutely.
what I think what you've mentioned there can be brought down to the STEM subjects or even STEAMs, which is the science, engineering, mathematics, technology, and even arts with a little bit of creativity, critical
Mhm.
problem solving that comes into it. Are you familiar with design thinking over there to in this capacity?
Yeah, and I think that's gonna play a huge role because um, the farming of the future it's very multidisciplinary. It's going to be robotics, it's going to be software, it's going to be AI, it's going to be um, how do we create an experience for a customer or an end user to be able to get food on demand, logistics. There's going to be all sorts of things, packaging, food safety, mechanical engineering for the robotics, maintenance type stuff. There's going to be so many different jobs, and those jobs will be interfacing with products and platforms that have been designed by people. How does the data flow from point A to point B? How does the equipment work and actually physically, manipulate the plants or harvest something? And then how do you get that, to the next spot? And there's going to be a lot of design work that goes into those systems.
Love that. Absolutely love it. And I think similar to the US, Australia has the luxury of land. And I'm here in Queensland. And when you go further north in Queensland, you start to see a lot of crops in different types of environments, especially the regional towns with sugarcane farms and so on. And that's only about 4 hours drive from where I am in Brisbane. And because of the luxury of land, I think we still resort to that previous generation of the way you described it 50 years ago. We still do those monocrops and work with it. So you actually see very little integration of technology into it currently as well, even to date. So what's your advice for countries that have the luxury of farmland, but haven't necessarily taken that leap to integrate technology at a more foundational level?
Well, I think all technology starts out more limited and expensive. And with time, with investment, with further iteration, it becomes less expensive, it becomes more robust, it becomes more fully featured and easy to use. And so even though I think a lot of farms, as you mentioned, don't have a lot of technology integrated today, there's going to be, I think, sort of this sweep that happens over the next 10 to 20 years, which is the advent of these super low cost sensors, the Internet of Things, all of these little AI chips that can go into these low powered electronics. And, even though it's expensive today, in a couple of years, a farmer is going to be able to, make their farm a smart farm relatively affordably, relatively easily, in the same way that we've been seeing like home automation really take off in the last 10 years with the smart light bulbs and all of these internet connected, air purifiers and smart appliances and all that stuff. That's become very affordable and easy to use for the average person very recently. And I think one of the next frontiers for that type of equipment is the farm. You'd have to be kind of on the cutting edge today to implement those things. But fast forward 10 years, every farmer is going to have a drone that takes off in the morning and does a sweep of the land and takes the data, and it just gets uploaded to the cloud. And, the drone is a few $100s. It's not, like a $10,000 thing. It's relatively affordable. And with that data, it all gets sent to the smart irrigators. They're all internet connected, and they're almost as the same price as a old school manual one. So there's going to be a big sweep that happens, and anybody who doesn't isn't paying attention or decides oh, I want to do it the old way, I think they're not going to be competitive, because the new way is going to allow a farm to operate more efficiently at bigger scale with fewer human resources. And if you can do that, you're going to have a more sustainable product. You're going to have a less expensive product, lettuces or vegetables or sugarcane or whatever it is. And that's the name of the game when it comes to these like commodity crops, is sustainability and the price that you're selling your goods for.
Perfect. I think that's well said. And this is leading straight into my next question, which is, when you're looking at that iteration of what's going to be ahead of us in the next 5 to 10 years and how this industry is going to look like, do you think the current education system is aligned with that?
I think it's slowly moving towards that. Right. The education system is a big ship. It takes a while to steer it in a new direction.
Yeah, absolutely.
Um, there are absolutely a lot of cutting edge programs that are very much aligned in that direction. So a lot of our customers, our universities and high schools that have 4-H programs, or Future Farmers of America type of stuff, ag clubs, and those types of programs are investing in what they see as the future of ag, which is heavy technology focus, robotics, software, AI, that type of thing, genetics. And so those types of clubs and educational programs, they're investing in technologies like FarmBot, and that I think is training these future farmers in for the agriculture of tomorrow. Anybody who still has maybe a traditional ag program, those are awesome skills, and people do need to know how to take care of animals and be able to grow a garden at home manually. That is super important skills. I don't know if it's necessarily going to be as marketable as a career path, or as something that you put on a resume for a job in 10 years. People might look at that and say, well, that's cool, but that sounds like a hobby. Do you know how to reprogram the drone to get the data that we need to make sure that the smart irrigators are working? And if somebody doesn't know how to do that, that's not going to be they're not going to get the job compared to somebody who does.
Absolutely. Yeah, well said. So on that note, what's your advice for students and graduates, whether they're in secondary, tertiary, and they're looking at the possible aspiration of agriculture? What's your advice for them?
I would say look at the way technology is progressing on just in a general way, and think about how that applies to the farm. Right. I think a lot of people think of farming as this old school manual thing. It's sort of dirty and low wage process that is kind of stuck in the past. And that is true to a degree, but technology has a way of kind of weaseling its way into everything, because it does save time and resources and makes things better in a lot of ways when it's applied properly. So look at the way that people, everyone's got an iPhone in their pocket now, or smartphone that has great cameras on it, GPS, an internet connection, an AI chip. What happens when you take all of that type of technology, the way that we work, it's all remote, it's all done through the internet, basically. How do those types of technologies apply to the farm? Because even if they don't apply today, it's coming. And so thinking about that future and imagining what it's going to be like is going to set you up to live in that future when it comes.
Perfect. I love it. And obviously one of the biggest challenges right now for educators is they're teaching what they've known, what they've lived for the last 20, 30 years. But then there's this huge transition, and students wanting to uptake with being digital natives and these technologies evolving more faster than ever before. What's your advice for the teachers that might have to guide the future generations of future farmers?
I think it's also trying to imagine what the future is going to look like. There's a lot of stuff that exists today or that has existed historically, but there are new technologies coming out, FarmBot, a lot of work with genetics, all of these drones and big data, neural networks, all this stuff. So getting students involved and exposed to the what's next, right? Not necessarily what is available today right now or has been the status quo for the last 2,000 years, or however long agriculture has been around. looking at where things are going is going to be what sets students up the best, and investing in activities and curriculum that sets them up in that way. Something that we're doing at FarmBot is we are developing open educational resources. It's free curriculum for how to use FarmBot technology in the classroom and teach related subject matter. So soil science, biology, sustainable farming, the economics of running a farm business. All of these things, tie into the FarmBot technology. And FarmBot's awesome in the classroom because it's hands-on, it's internet connected, so students are excited about it, and it's kind of familiar. You use an app to control it. It's something that young people are familiar with in a way because it's technology and it's fun and new, and it's exposing them to a field that may not be that exciting to them on the surface, because they think of farming as something that's a little more old school and something that is not gonna get them to where they want to be in life.
Yeah. I think that's beautifully said, man. And obviously FarmBot, I'm a fan of it. And can you please share how people can get in touch with you if they want to learn more? And obviously we'll feature some links into the show notes as well. But how can they get in touch with you if they want to learn more?
Yeah, so if you just Google search FarmBot, we should be the first thing that pops up. And our website is farm.bot. And we have all sorts of resources online. So we have obviously information about the products themselves, but also the documentation for the hardware, how to build the FarmBot Genesis or FarmBot Express systems, information about how to use the software, everything from planting your first garden to doing advanced sequences where you can really control every little aspect of the FarmBot. There's ways to, if you're doing computer programming, you can control it from a third-party software that you author yourself. We have the Open Educational Resources Hub for teachers, and anybody who's doing an educational project around FarmBot. There's a whole lot of information on our website, and then you can also look up #FarmBot on social media, Instagram, Twitter, and see content from us as well as our customers and other schools and universities all over the world who are learning and growing crops and coming up with new designs for hardware and software that make FarmBot even better and do new and exciting tasks. So just search away, and there's a lot of information to eat up.
Love it. And I think this is the kind of work that excites people because there's a lot of value in it for humanity in general. You're aligning with the United Nations SDG goals. You're actually doing something you enjoy, playing with toys and technologies. I love it. So thank you so much, mate. I've learned a lot. This is not an industry that I'm too familiar with personally, but you've dropped some real knowledge on everyone, and I'm sure the listeners took a lot away from it. So thank you so much for giving up your time.
Awesome. Well, thank you for having me. This has been fun.
My pleasure.
That's it for today's episode. Now it's time to take action and build on the learnings to get inspired. First up, jump onto roshansenanayake.com/podcast and check out the show notes, links, and other relevant learning materials from this amazing episode. Next, if you learned something new today, click that subscribe button and set yourself up to receive live notifications on future episodes, as well as more opportunities to learn from our amazing guests, brands, and speakers. Last but not least, it's time to have your say. Join the conversation and share your thoughts and feedback on today's episode with a review, all while joining many others with a 5-star rating for Inspiring Design with Roshan Senanayake. Till next time.